The Coriolis Effect is an apparent force that occurs over long distances on the Earth's surface. This force appears due to the rotation of the Earth's surface while an object is moving northwards or southwards. Normally, when an object moves along a plane, one that is not moving, it travels in a straight line to its endpoint. However, on a rotating plane, like the surface of the Earth, the plane moves as the object travels in a straight line. While the body doesn't physically change the direction of its path, the plane underneath it rotates, causing the object to have a different endpoint than it would have on a non-rotating plane. In this conceptual example, you will notice that the marker travels in a straight line. The ruler does not move, and the rotation of plane does not change that. However, it does change the apparent path, causing it to deflect to the left. In this real-life example, the ping pong ball moves in a straight path with a velocity. As the frisbee spins, the ball ends up being deflected to the right. This is what happens in the northern hemisphere. The ping pong ball is then shown being deflected to the left. This is what happens in the southern hemisphere. Note that the ball never changes the direction of its velocity, it only changes the apparent path.
It is important to note something that was mentioned in the beginning. Coriolis occurs over long distances on the Earth's surface. This is because of the equation that defines whether Coriolis is relevant, the Rossby number equation. If the Rossby number equals a value less than 1, Coriolis is apparent, or it is the dominant force. As you can see, if the distance traveled by the object increases, the L value, the denominator increases, and this causes the Rossby number to be smaller. This is why the Coriolis typically occurs over long distances. It should also be noted that slower moving objects can cause the Coriolis to become apparent since lower velocities will lower the value of the numerator, the value u.